I know all my A-level students will be very excited about this video. This is for solving exponential equations. I'm very passionate about this topic, and so I did this for my A-level students. Please make sure you stay tuned, grab your calculator, and get on. Let's solve some exponential equations. So we're looking at solving exponential equations. Exponential equations are very fun. They are those equations that involve the unknown variable in the power of our equation. So instead of having 2x at 3, we might have 2 to the power of x equals something. For example, we could have expressions like 2 to the power x equals 4 to solve for x, or we could have 3 to the power x equals 9 to solve for x, or we could have 2 to the power x equals 5 again to solve for x, or even to make it more tricky and a little bit complex, we could have 2 to the power 2x minus 6 to the 2 to the power x, and then we could have, say, add 8 equals 0, and you'll be asked to solve for x. In all three different scenarios, being the first part, which is straightforward, and then the second part and the third part, we're going to look at all of them and see how we might be able to use these understandings to solve problems. Okay, so this is particularly for those of us who will be doing A-level maths this year, and I'm particularly targeting that because a lot of my students are asking for this. So feel free, grab a calculator, and let's get into this. Okay, so looking at the first scenario where we have 2 to the power x equals 4, we can see that basically if 2 to the power something is 4, everybody knows, yeah, well, 2 squared is 4, but where is that idea come from? 4 is the same as 2 squared, so 2 to the power x is equal to 2 to the power 2. What we say here is if the bases, i.e. these big numbers here, they are called the bases. If the bases are the same, we say then the powers are equal. Okay, so you want to remember that if the bases are the same, then the powers are equal. So we can say since 2 is equal to 2 on both sides, then the powers must be the same, so x must be 2, and we can check that 2 to the power 2 is 4. We could use the same idea to solve for 3 to the power x equals 9. Okay, so we could say that 3 to the power x is 9. Basically 9 is the same as 3 squared, so this 9 is the same as 3 squared, which is of course 3 to the power x here. Again, by our statement, if the bases are the same on both sides, then the powers must be equal. Again, we've solved that. It could be even more fun, like example, we could have 3 to the power x equals 81, and sometimes it's not straightforward to see it, so you could say again, is there any way I could write 81 as a power of 3? Remember, we want to make sure the bases are the same. Now 81 is the same as 3 times 3 times 3 times 3, so we could write that as 3 to the power of 4. And here we've got 3 to the x equals 3 to the power of 4. Again, we notice that the bases are the same. So we see once the bases are the same, the powers are equal. So x must be 4. That is again a straightforward one. We're going to look at one where we are not able to make the bases the same, and that's where we'll be introducing logarithms. Okay, so if you've not done logarithms before, I'm sure around by this time, if you're preparing for exams, you should know logarithms. Again, watch out for my video on logarithms and we could look at that. Okay, so if I want to solve for x in this situation where I'm unable to write 5 as a power of 2, I could do what we call logarithms. So I could say we could say natural log of both sides, or log to base 10, or log to any base of both sides. Okay, in equations, what we do to both one side, we do the same to the other side. So I could say take natural log, and I'll show you what that means. Natural log, or logs of both sides. Okay, so on this side, natural log means that natural log ln 2 to the x, and here I've got ln 5. Okay, Now there's the third law. This is where we have to be very good at applying our third law of logarithms. The third law of logarithms is the power law, where the power drops. Okay, so we apply our third law of logarithms. Apply the third law. So here the power drops, and we're going to have x natural log of 2 equals the natural log of 5. Natural log of 2 is just a number. So basically we are saying x is times by something. Okay, if I want to solve for x, we do that the way we learned from GCSE. I'll divide both sides by whatever is multiplying x. So here the natural log of 2 is multiplying x. So I'm going to divide here by the natural log of 2 and divide here also by the natural log of 2. Let me write it carefully. So we've got x being our natural log of 5 divide, which is our fraction line, the natural log of 2. Sometimes exams questions might say leave your answer in the exact form, and that might just be what you have to do. You might just have to leave your answer like that, or it might say give an answer to 3 significant figures. What you've got to remember is that A-level questions are usually expected for answers to be to 3 significant figures. So where you are asked to leave your answer to a decimal or to 3 significant figures, we then go to our calculator. Okay, so you grab a calculator. Natural log is just next to your log sign, log. Okay, so we press the natural log of 5 and then divide by the natural log of 2, close brackets. Okay, and then on your calculator you should have x equals 2 to the 2.321928 and so on. To 3 significant figures, x will be 2.32. That means that if I have 2 to the power 2.32 thereabout, my answer should be 5. And this is a very simple one of solving exponential equations, where we cannot make the bases the same. Now it could get more complex, where sometimes what happens is that quadratic equations are involved, and this is very, very subtle. Examiners don't expect you to know this, so you have to be smart to identify this. So we're gonna do our third example. Okay, our third example, we've got it all the way here, which is 2 to the power 2x minus 6, 2 to the power x add 8 equals 0. So this will be the example we'll be doing. So get ready. If you are ready, prepared for exams, you want to have a go and then look at what it is, that's fine as well. So let's look at this. 2 to the power 2x. So I've got 2 to the power 2x, take 6, 2 to the power x, then add 8 equals 0. Okay, so to solve for this, what we want to try and do here is replace 2 to the power x. And it is always very important to look out for patterns when solving maths. It is the same thing, just like you did in your GCSE exams. It is the same thing you do in your A-level. Patterns are part of maths, and that's for life. So everywhere we go, there's pattern everywhere. Okay, so the pattern here is, how can I write 2 to the power 2x as 2 to the power x? Now by the law of indices, 2 to the power 2x is the same as 2 to the power x all to the power 2, because the power law of indices says x times 2 is 2x. So we know that x times 2 is the same as 2 times x, and it don't matter which way I write it, okay, it will still work. So I know that whether I have x and bracket 2 is the same as 2 and bracket x, again that don't matter. So I know that is the meaning of that, and I've got minus 6 then bracket 2 to the power x add 8 equals 0. Okay, so what I'm gonna do here is, let's try and separate this so we don't get confused. What I'm gonna try and do here is try and replace 2 to the power x with a letter that I'm convenient with. I love to use my favorite letter. My favorite letter is C, because I support Chelsea. Guess what? So I'm gonna use C for Chelsea. So where I see 2 to the power x, I'm introducing a letter. Sometimes in textbooks you see y being used, because x and y seem to be friends of maths. People don't like it. Sometimes I love it, but of course I love my favorite letter, C. So I could say let 2 to the power x be C. So I'm gonna replace it with my favorite letter. So instead of writing 2 to the power x and then squared, I write C squared minus, here I write 6 loss of my 2 to the power x, which is C, add 8 is 0. Now at this point, I could factorize, I could use quadratic formula, I could use completing the squares, I could use whatever method helps me to solve a quadratic equation. Okay, so I could see easily that it is easier for me to factorize. So I'll have my factorizing done. C and C, because this and C is C squared, again from your GCSE. Okay, and then we got minus 2 and minus 4, because minus 2 times minus 4 is positive 8, and minus 2 add minus 4 is minus 6. This equals 0. What this is in C is either 2 or C is 4. Okay, now remember, I introduced C. You introduce your favorite letter. Your favorite letter could have been M, it could have been N, it could have been Y. You've got to go back to solve the question, because the question involved X and not C. So I'll say when C equals 2, basically I am saying that is my 2 to the power X, which is 2. So like we saw from before, the bases are the same. So what must the power be? 2 is the same as 2 to the power of 1. So that means X is 1. So that's the first solution I've got when C equals 2. Now I'm going to work out for when C equals 4. So when C equals 4, it means I've got 2 to the power X equals 4. 4 as a power of 2 is the same as 2 squared. Okay, so 2 to the power X equals 2 squared. Once the bases are the same, I can conclude that X equals 2. That is what it is. Now it is that easy. Now go on, get your textbook, do some more practice of this, and I hope to hear the good news. Share, like, and subscribe to this website and the YouTube link. Thank you for listening. Well done, you legends. Now you can solve exponential equations. I'm so excited about that. Thank you for watching, and please don't forget to share, like, and subscribe to my YouTube channel, and also visit my website at ninsonsmathsolutions.co.uk. I'm gonna put some fantastic resources there for all of you. Well done.